Most particles, like electrons, protons, and neutrons, have spin. Now this is a measurement of angular momentum that is intrinsic to the type of particle it is. For electrons and protons, there are only two possibilities, so we represent this as a positive and negative quantity. The actual magnitude of these can be represented by this equation, where we have h bar as Planck's constant divided by 2 pi. Now, anytime we have a charged particle with spin, it ends up creating a current. Therefore, it's like a small loop of wire that has a current. As a result, we can say that it has a sort of magnetic dipole moment that can be described according to this equation. Now, this gamma represents the gyromagnetic ratio of the particle. This is an intrinsic property dependent on the type of particle. So a proton has its own gyromagnetic ratio, an electron has a different one, and so on. So we discussed before that if we place a magnetic dipole in an external magnetic field, we can quantify the energy of that situation according to this equation. So if I carry through this equation that I have right here into mu, I end up with this expression for the two energies that are available for my two different spins. Now, as I increase B, I end up seeing a bigger difference between these two energy states. So if I plotted this on a graph where energy is plotted on the y-axis and the field strength is plotted on the right axis, I can see that I have the positive energy getting higher and higher and the negative energy getting lower and lower. Now, in order to be able to talk about these spin states, we give them certain terms. The lowest energy spin state is always referred to as spin up, and the highest energy spin state is always referred to as spin down. Now, the change in energy between these two things ends up just depending on how strong our magnetic field is. If I take the difference between these two, I end up with this equation, which only depends on some constants associated with the particle and just in general, as well as the strength of magnetic field. This difference is really important, and this underlies the whole principle behind NMR, MRI, and all sorts of biological and chemical spectroscopy things that you may have seen before.